Hello, welcome to Topper Machine. I'm Josh Topper, and if you follow the channel, you know the Lion lathe, and you probably notice something is a little bit off. Yes, it is a much bigger chuck. I just bought this to do one job that's a repeat job that I took over from another local shop, and let's get into that, show you what it is. All right, so right here is a sprocket. These are 19-inch diameter, and they start out with just a little pilot hole, and I have to bore these out to just under 3 7/16. And what they do is they mate to a shaft that then gets a shrink fit, a 3,000 shrink fit. Keyed also, so I still have to key this one. This one's been bored, it's ready to go. This one's ready to go up in the lathe. So let's get this one bored, and then we'll get it up all on the slaughter and cut the keyways. All right, so I got her up there in the chuck, and we're chucked up on the outer diameter of it. I found that over the years, the OD is a little bit better than the ID. If I chucked on this, I actually wind up with a lot of wobble out here on the sprocket, so we're gonna true it up to the OD of the sprocket. And this little lifting apparatus here is one that I built specifically for this job. I haven't seen this job in a couple of years. What the customer was doing was ordering the sprockets from Martin and then having them bore them. Martin upped their price considerably. And then they were having the shafts made elsewhere. They were having problems with fitment and that. So I'm doing the shafts and the sprockets. This is 2 sprockets that go with shafts they already had on the shelf to finish out this little bit. And then I've got a bunch of shafts to make, and like 9 shafts and 9 more sprockets. So I bought the bigger chuck just to get this job going. I used to do this on the big Monarch. So when I had the big Monarch, I had a chuck this size and did it exactly the same way. It worked great. But the Lion, I threw this big chuck on here, you know, figuring this was just a one-time deal for these parts, and it handles it very well. So no concern there of the weight. I'm not putting a lot of weight on it, not a lot of stress, so it's definitely not a concern for me. So when I did the first one, I used my little twist drill. That's a 3-inch 5 Morse taper twist drill, and I opened it up and then bored it from there. This one, we've got a new tool. So UPS just got here, brought this from MSC, because they had the best price I found. And what this is an Allied spade drill. And I also bought the 3 1/4 inch spades to go with it. So let's get this thing set up and start drilling this thing out. All right, we're all set up here. Got the 3 1/4 inch spade drill in there. I put a little bit of Never Sees on the screws before putting them in, and then I set up my coolant supply. Now let's see what this looks like when I turn it on. They're definitely bigger ports, and the Lion doesn't put out enough coolant with this little puny pump, but that'll be good enough to get us through this. So let's we're gonna run about 31.5 RPM, run slow. We're gonna bore through this hole is not going to be centered. You're going to see that real quick. So let's get going. Boy, I am actually surprised that's running as true as it is. Most of the time that hole is wobbling pretty bad. They're not centered. It's a pretty rough deal there. I'm not liking how I'm not getting coolant up high, so I'm going to run a little more with the nozzle just to help that cutter out and everything, and I think we're going to be in pretty good shape here. So much better. Alright, so I'm just into the middle section of the sprocket here, and you can see the chips are coming out a lot different. It's a slightly different material. So the outer rings that are welded on are just a little bit different than the actual sprocket, and that does make difficulties in boring. And like I said, you see the chips are getting a little stringier instead of the nice tight little curls. I'm feeding exactly the same. We made it through. Check out these beautiful chips. I mean, just big, heavy, beautiful chips. Them spade drills do an amazing job. All right, let's just see how it did. Just by the caliper, I'm 3 over, 4 maybe. These spade drills are absolutely incredible, and they make a nice finish. So I'm going to go ahead now and we'll switch over to the boring bar and start boring this thing out, get it close to size, and then we'll finish it up. Alright, I sped it up. We're going to run at 250 RPM now. We're going to throw what coolant is on the chuck jaws everywhere. Yay. I'm just going to take 50 in a pass just to, because this is actually some tough stuff. It's kind of weird. that chatter you're hearing as we hit the center material. I don't like that. I might have to slow her down to combat that. Let's see if I can get through it. Yeah, so the center plate of the sprocket is different hardness or whatever, and it's not happy. So we're gonna have to slow down to get through that. If you look down there in the bore, we had a nice finish out here, and then we got a lot of chatter right in that center section. So I'm gonna definitely slow it down. We'll try to get through that, and should be able to clean that up no problem. All right, so I dropped it down to 125 RPM. Take another 50, and we'll see how she does. All right, we're just coming up to that spot. Actually, we're in it, and it's cleaning up just fine. Just get a rough measurement with the caliper, see where we are. And I got about 100 thou to go, so we're not even going to take that. We'll take probably, we're going to take another 50. We'll do it in passes just to keep the chatter down. All right, so I'm really unhappy with how this boring bar is performing, and what I think is going on is this is a 643 insert. It's a large radius. I think that's giving me too much surface tension, pressure on the tool, you know, this. I think I need to go to something a little sharper, and I don't have any. So this is what I usually use on those cast iron wheels I turn. I do have my 432s with my smaller bar, and I can extend it out enough to get it to go through. I think I'm gonna try that. All right, so we're all switched out. This is an 1 3/4 boring bar running a CNMG 432. I'm hoping this will do a little better. In fact, I'm gonna speed it up to 180, and then we'll just take a light cut, true everything up, and see how it looks. That already looks like it's cutting better. already a much smoother surface finish. That made all the difference in the world right there. So we'll go ahead and measure up the bore, see where we're at, and then try to finish this thing up. .418, and we got to go to 433. All right, I've sped it up again. I'm going to run 355. Slowed down my feed rate to get a nice smoother finish. Let's bring it in. I'm going to just take, I need 15, I'm going to take 10. Just to get close, and then we'll clean it up, you know, take a last pass. In fact, I'm going to measure it first right there. It's just a quick measurement to see where we are here. 427, so we're still good. We're under. We want to do this in a couple passes just to make sure we get it right. So I had just stopped the camera to change the angle, and it started to chatter when it got through this first bit here. So I am going to slow it back down to 250. All right, we're going to run 250 and see if we got it there. So we'll just have to recut this very carefully. I think we'll be okay. We still got a little bit to go. Alright, we're just coming into where it started chattering before. I took an extra 1 thou on this pass just to touch it and clean it up a bit. Let's see how it does if we can get through this chatter. So far that sounds good. So 355 was just a little too fast. 250 is about right. Because of how I had that chatter and I had to slow her down, I just slowed it down a little bit more. I'm going to take 2/1000ths, take a little bit on the end here, and then measure it and see where I'm at. It's like I gotta go 1 thou more, so if I go 3, we should have that board. All right, now I'm going to take my bore gauge that I've already got set to 433, which is the size we're finishing at, 3.433, and I just checked the bore all the way through just to make sure we're good, and actually we're looking really good. Just a little loose there on the far end, but we're good in the middle. So that could be the discrepancy of the 2 different materials in this thing. So we're still good. We're within tolerance. So we're perfect. I'll just take the handy dandy little deburring tool here because we don't want much of a chamfer on this. We'll just deburr that, and we're good to pull this one out and do the chamfer the other end, and then we'll go over to the slaughter and set up and cut the keyways. So I got the first one set up here on the slaughter. We're going to cut a narrow keyway first to take the brunt of the cut, and then switch over to the wider key cutter, to the 7/8, the finish size. And if you're wondering about the setup, there are other videos on the channel of this machine being set up and doing some pretty cool stuff. So check those out. And the other thing I added this go around is a coolant pump with oil. And we're gonna try that out. This is a temporary setup to see if it even works. So as you can see, I got a bucket set up here off the table drain, just a quick setup to a coolant hose. And we'll just let that dribble as we cut. See if I can turn it on here. That may be enough flow right there. We'll go ahead and start getting the cutter close, lined up, and start cutting this keyway. So I decided to slow it down just because this is some harder material, and up the oil a little bit. Well, we're almost there. I'm going to stop and measure it here. All right, we got a little bit further to go, so we'll just keep on cutting. $35 to go. Alright, we should be at depth. I'll just probably measure that just one more time, make sure. But I'm pretty sure we're good here. Oh yeah, we're good. We're good. Now I'll switch out the cutter to the 7/8 and we'll go ahead and just finish it off. think we're there. There it is. We are actually all done. This is probably one of the worst keyways I've ever cut. This is some tough material. And actually it's an interrupted cut. There's 3 pieces here. So you got the top piece, the sprocket, and then the bottom piece just like this one. So it's an interrupted cut. I'd say it worked pretty well. Well, I'm going to end the video right here. I hope you enjoyed this. The boring to a tight tolerance for a shrink fit, and then the keying. And then next week we're actually going to make one of the shafts for this sprocket. So there's 2 styles. The drives were the ones that were on that pallet ready to go that the other supplier had done, and the idlers are the ones I'm doing right now. So I'm gonna get this out of here, keep going. I've got 4 more of these to do today. I have 11 in total, so I gotta keep moving. But until next time, get out in your shop and get it done right the first time.